But hey, I'm Z. I'm the lab assistant at BetaNYC. I work with the fellows, but I also do a lot of data projects related to helping elected officials or community members in understanding open data. And let me start sharing my screen, I guess. And one of the large projects I've really just been really like involved in and really passionate about is like the pedestrian space. So how do we more um, equitably like start thinking about how street space is shared and how accessible it is and all that stuff. So one huge data source I use a ton of is OpenStreetMap. Not only for the building data, for the road street data, but also for various other data sets like amenities. We During COVID, we did a lot of stuff relating to businesses also, and supermarkets and all that stuff. And we've been working on this. We've been chipping away at accessibility issues with pedestrian ramps and sidewalks for a long time. And this really started to kind of roll from last year's, 2019's National Day of Civic Hacking, where we kind of mapped a ton of sidewalks. We had like a ton of volunteers help us out. And currently now we have a ton of sidewalks already mapped. And I just want to show some really simple examples of how to create some network analyses to kind of use that data that we now have for some neighborhoods in New York. So I guess let's get started. So the agenda, just to keep in mind, is just I'm just going to go into why we want to measure pedestrian routing and mobility. What metrics do we want to collect, and how do we collect that data, and how do we process that data? So I'm going to show some really simple examples in QGIS and in Python about just really simple elevation. Elevation really plays a huge role. I'm going to show on other slides, but essentially it's very hard to walk for older folks or people with disabilities to go up just the simplest of inclines on our streets. And then we're just going to have a quick discussion in QA. I'm no means an expert in the OSM data set, and I always like to hear suggestions and feedback. So let's go ahead. The metric I use a lot is walkability, and I tend to use the walk score a ton because walk score has a really useful API to find how walkable an area is, or there's also separate indexes for, I think, biking and transit. I use this metric a lot, and New York City is when you think about walkability, New York City is a top walkable city in the United States. But there are some areas, if I use a laser pointer, some areas, of course, in Staten Island, more car centric. The out eastern Queens, which is again more car centric, and then some areas in like parks and all that stuff that is somewhat technically walkable, but the index they use might not take into account. And maybe it might be hilly. That's why the walk score is so low there. But I kind of think when I use this walk score might be too general. So this score doesn't really include a lot of metrics for people with disabilities, as I said before, the elderly and pregnant people who might have some issues going up inclines, or they might have barriers. For example, curb cuts or pet pedestrian ramps are really important in a ton of areas. If the lip of the curb is too high, a lot of wheels can't roll over. If you think of now that we kind of have the plastic bag ban, a lot of people are sort of rolling around grandma carts. Sometimes grandma carts are kind of really heavy. I think of all the grandmas in my neighborhood trying to kind of lift those carts when they're crossing the streets. If the lip is not flush to the road, it's kind of really hard for them to push it up. So. Again, not all streets are accessible, and there are a ton of barriers. So some paths don't really connect certain people depending on their mobility. So we kind of want to figure out a better metric of walkability. So I really like championing this term, pedestrian mobility. I know this is popping up a bit. Can I move this? No, cannot. Okay, I'll just try to not move my mouse that much. But yeah, pedestrian mobility is really important because it really highlights the other section of people who can't walk or have difficulty walking. And the city has been increasing this pedestrian mobility over a long time. So with Vision Zero, with a lot of safety improvements, with the pedestrian ramp project to just improve and repave a lot of these really bad ramps, and then with street widening projects and also the Open Streets initiative. So all these problems kind of like really help. I mean, all these solutions kind of really help increase pedestrian mobility, but how do we start measuring it and kind of measuring the changes throughout time? So how I kind of started to think about this is that there are a ton of barriers to mobilities we want to kind of account for. So the most current project I'm working on is planning for early voting sites in Manhattan. So if you look at the map for 2019 compared to 2020, 2020, of course, has a lot of sites, but there still has to be an issue with an increasing sites. So the most apparent issue that Manhattanites kind of complained about is folks that live in Roosevelt Island kind of didn't have access to any voting sites in 2020 and also 2019, since they kind of have to take the tram, or they also have to, or they take the subway to go to the Upper East sites. The Upper East Side sites. So that may be difficult. Another really difficult point into going to voting sites is if you're in any upper part of Manhattan, it gets really hilly, especially when you cross over from Harlem up to Morningside Heights or Washington Heights. You usually have to go upstairs or like a really steep sidewalk or slopes. So those are the things that I kind of want to think about when I'm measuring pedestrian mobility. This project is the most current one I'm working on. So what data sets can we collect to figure out these barriers to mobility? And I kind of want to just go back to the theoretical of how computers kind of model movements or networks in this case. So when you're doing, when you're measuring how people get to point A to point B, you're kind of creating a network of streets, and then you're trying to route people through these streets. So in a flatland, we expect to get from one street to the other at the same time. So in this case, 5 minutes, 5 minutes. This doesn't really apply to the real world because there's a ton of barriers between all these stops. So if there's a sidewalk that's closed, there has to be a detour. So that's going to take a considerable amount of time, extra time, because you're going to take more streets. Or if there is a elevation gain, there's an incline, it might take some extra effort and extra time to go to a location. So these are the barriers we want to kind of collect. And that's going to help us kind of model out our network and help us try to figure out where folks can go to. And at a certain amount of time or a certain amount of effort that are required. So again, I kind of love using elevation a lot as an example of the first issue, the first barrier, because it's the most visible seen barrier. Like a wheelchair can't go up stairs, or a wheelchair or a baby stroller is going to have difficulty being pushed up some steep ramps. And in this case, this ramp is really good grade and a good incline, like a really gentle incline. So it's really easy, or it requires less effort than like a really steep staircase. In 2019, again, I want to point that out. There were no sites in Harlem, so folks have to just go up these steeper stairs. It just required generally longer distances, but also larger amount of effort. And this issue has been fixed in 2020 sites, but we can generally relatively do this analysis to try to figure out if there are any more locations. This is more like this. If you want more relative example, like a more relevant example than voting sites, because we're not in like a voting cycle yet. But there's a lot of people campaigning. We can think of COVID sites. So there are a ton of COVID testing sites or vaccination sites, and we want to have them in places where older folks can get to them without taking the bus or transit. And elevation is one of the top things we want to keep in mind. Another barrier is a barrier that's near and dear to my heart again is pedestrian ramps, which allows any people to really easily get onto the sidewalk when they're crossing the street. So sometimes these get flooded, sometimes they're uneven, and it just generally causes a lot of issues. The DOT has been working on this issue for a ton of years, and they've released a ton of good data on it, but it's not very connected to any of our networks. So we kind of have to map this data ourselves and then use DOT data as reference to kind of collect that data if the ramp has a tactile pavement, if it's 2 grade, if there is if it's accessible. So the data is out there, but we kind of have to collect the data and convert it over to a format that we can use with our network. Another barrier another ton of other barriers that I just want to group into path conditions is that some sidewalks are crumbling. Sometimes there are tree roots that kind of bring them up. That's really hard to kind of go through the sidewalk consistently. That can kind of be marked on a network as a barrier, as an absolute barrier, because you can't really get through. There can be a sidewalk width issue. We'll talk about this more later, but essentially, yeah, if there's not enough width, then there might be some issues with enough traffic going through it. Or in this case, I really kind of hate this if you're from New York and you take the East River Greenway a lot. There's this choke point here, and this choke point is mainly for this choke point is for pedestrians and bicyclists. But yeah, you usually have to really it only can allow one person to go through it at once. So if there's 2 bikes going on separate directions, you just have to really awkwardly nudge to the side of it. But somehow a car got in here I think a year back ago. And yeah, I have no idea how. Other conditions can also be the surface. So not all neighborhoods in New York have paved paths in some areas. I've been hiking in Staten Island, which is pretty cool. And yeah, they have paths that have not been paved and it's just ground, but a lot of people like pushing their baby strollers throughout there. We have to think of when it rains, it can get muddy, or if there's a little bridge, how wide is that bridge and how can that allow for people to cross it? And then probably on your mind right now is snow. Yeah, how quickly is snow being removed from our paths? And lastly, this is freshly made asphalt. So yeah, we can also think about path conditions as smoothness too. So there's a lot of barrier data and path data we can collect about our network, and then from there we can create these analyses of how well can we travel throughout the city. Just really quickly, other factors. Lighting, you don't want to cross a park if it's not well lit. There's also psychological barriers, places where there's a lot of highways and underpasses that don't make it really particularly inviting to cross areas, especially if there's a ton of trucks along the way, or dangerous streets that don't really allow for people to cross safely. So those are other considerations. And yeah, there are more considerations. I'm just going to, again, go through really quickly. I'm just rambling on right now, but essentially if there's a construction project, yeah, sidewalks closed, you have to go on the other side of the street. Some open restaurants, not so now because there's a lot of enforcement on it, but some open restaurants might take up the full street, which is an issue. There might be cars parked by the ramps. There might be police vehicles parked in the sidewalks, or police precincts blocking off whole streets. And then there's a discussion of capacity about our roads. Some areas where there's a lot of tourism, like Herald Square, or more densely packed streets in Chinatown, there might be some issues of routing folks through there because there is just not enough room for social distancing, or there's not room for just, in general, a lot of people to travel through these tight spaces because there's crowds of people. And I won't discuss this here, but there's also considerations for connectors to other modes. When you're doing mobility analysis, you're not only doing it for people who that walk or on a stroller or on wheels. You also want to kind of connect them to other modes, which kind of makes it much more useful to travel to other parts of the city. So if a bus has a loading platform, that kind of helps widen the sidewalk, but also helps people with wheelchairs get on the bus a lot more quicker. If the elevator's closed, you can't really go to that station and ride the subway there. And you always want to kind of find bicycle parking if you want to kind of stay in the neighborhood for a bit, or walk around and not be on your bicycle all the time. Or if you're going back home, you want to kind of find a place to park it. So how do we find and collect this data? So there's a ton of open data out there. The primary source that we all think of is probably the New York City sidewalks data set. New York City sidewalks data set can be a base data set, but I don't like particularly using it because it's a bit outdated. It's using 2016, it's using 2016 planimetric data, which is via like various flyovers, and then that kind of generates these 3D models. It's kind of outdated, so I don't really like using it again. But also it doesn't have connections through crossings. And lastly, it's a polygon layer, so it's kind of really hard to build into a network that we can kind of route people through, because polygons are kind of really clumsy. Melly's gonna be presenting an event on Saturday, so it's kind of interesting. She worked on the Sidewalk Width project, which kind of has this algorithm to convert the polygons over to lines, and then these lines also inherit the widths. So this might be a really interesting way of maybe deriving the sidewalks polygons into a more useful data set, but still it's a bit outdated for me. So I'd really like using OSM. I'm going to talk about that later. Another possible like data set we can use is Lion, which is New York City's street like data set, which includes like all the segments. But it's a bit overwhelming sometimes with all the columns that we have to kind of convert over. And also it doesn't really include a lot of the park paths that we kind of need, that some people kind of prefer to take instead of taking like a really inclined sidewalk. And Google, we can always use Google data, but Google data is kind of proprietary. And also when you want to add routes or paths, it kind of goes through a process. And it usually takes some time to update that data set. So that kind of brings us to OSM and why we want to kind of use OSM. OSM is kind of the Wikipedia of maps. You can view all the data on a website. If you want it on your phone, you can. The MTA uses it sometimes. A lot of other industries kind of use it through the service called Mapbox. So like Snapchat kind of uses it. I think Facebook derives a ton of data from it. And it's just generally free and you can openly view it. The most important component of this presentation, you can download OpenStreetMap data and you can use it towards your analysis. And lastly, you can contribute it. You can contribute back to the commons. So if you have a path you want to kind of add, or if you want to add special considerations like, this ped ramp here does not have a tactile pavement, so people with disabilities can't see it. Can't feel it, or can't see it. This might be a difficulty of getting onto it. So there's a lot of attribute data you can kind of attribute to the information, and other people can use your data that you contribute. Again, this really started as a process in the National Day of Civic Hacking, where Eric here and Daniel Slow is a really huge mapper in New York City. He's been working on a lot of projects. He also has an event, I think, next weekend. He's going to host this virtual mapping event for all bike infrastructure in New York City, where you can do in your own neighborhood. But essentially, they kind of presented and created a challenge in a National Day of Civic Hacking 2019 to map a ton of sidewalks throughout some vulnerable community districts. And that kind of helped us map a ton of New York City, but we still need a lot more. So afterwards, Daniel added a ton more tasks. One of the tasks is in my community district in Flushing, where I just want to give a shout out to Wire Guy. He's been working on like incredible amount of the tasks in Flushing, and we almost have Flushing all mapped. So I'm going to be using Flushing as an example for routing, since it's nearly all mapped, and we can kind of get like a really, really cool looking mobility map out there. Yeah, again, OSM is really cool because you can store a ton of attribute data. So like even for sidewalks, you can mark if the sidewalk is marked. If it's unmarked, if it allows for cycles, bicycles, and then if it's raised. So I don't think we have these in New York, but yeah, you can mark if it's raised too, which is pretty cool. There's also a ton of other attributes. You can go into Wiki to kind of look into it. You can mark it with smoothness. Smoothness is kind of subjective and kind of a controversial tag in OSM, but it's still good to have, and sometimes really good to mark if like a road is really, really worn down and broken, compared to if it's like just an excellent, like freshly paved asphalt road. There's tags for tactile pavement, a refugee island, wheelchair access, and then like the height of the lip. So you can get really specific on the components you map in OSM, and it kind of really helps contribute back to how you want to map for mobility. Lastly, there's a ton of community data. So like this is from my personal experience. I just love learning about something and then just like finding out it wasn't mapped. And then I just throw it into OSM. So I found out there was this shortcut this shortcut through this amazing community sculpture garden, do a presentation through CUNY. It's called Elmhurst Sculpture Garden, but essentially if you don't want to go through like the sidewalk by QCM, you can always go through this amazing little garden / park by the highway, which is pretty neat. And also, there's been huge redevelopment in Flushing by Flushing Creek, and there's been a lot of environmental studies that are just popping up, and I just added a couple of paths related to all the creek paths you can kind of walk through. So you can really just throw all your community knowledge on there. It's pretty cool that you're actually mapping and exploring and finding new things. But there are some difficulties with OSM. Some data in areas can be sparse. I'll show in my next slide. I'll show you like where all the sidewalks are kind of mapped. But essentially, OSM kind of is because it's community based. It's really reliant on who in that area wants to map that area or what big company wants to map this area. OSM has recently gotten a lot of attention from Apple and Amazon because Apple and Amazon are trying to invest more resources into improving OpenStreetMap so they can get better routing also for their cars and vehicles and trucks. But also, like for community mapping, this also relates to demographics of mappers. For most cases, mappers of OpenStreetMap usually are from a certain demographic. They're mostly people that live in higher income, that have more computer skills or have transportation backgrounds. That's why a lot of like railroads or a lot of subway stations have these really complex maps. But if you go out from a transit station, you can only see like buildings and then some basic street structures. So like there's a ton of like areas of New York that haven't been mapped, or there's a lot of attributes like ped ramps or street and sidewalks that have not been mapped because there's no interest or there's no demographics or company interested at mapping this. So we kind of get to here. So today we kind of have a lot of these. So these two shapes here are, well, I think these three shapes here were projects for the OSM PetaRAMPS mapping project. So most of these are almost mapped. Some of these were mapped entirely by Daniel because he has an incredible love for mapping anything in New York City, especially in areas of Astoria where I think he currently lives. And also there's just a lot more mapping going on in Lower Manhattan because all the tourists and stuff like that. But essentially, yeah, we kind of don't have a lot of New York mapped, and we still need it mapped. That's going to be something that I'm going to continue working on, so we can eventually route throughout New York City and also get a lot of like higher quality mapping and mobility data. So we currently have only a few ped ramps in Flushing, which I'm going to map at. But just having that data there will help us define really concrete filters so we can then figure out where there needs to be fixes of ped ramps. So that brings us to a really awesome existing sample from Seattle. So Seattle created this axis map, I think, almost 4 years ago. They essentially imported and QA'd all of their city's sidewalk data, and then they added slope data to their tool, which then allows you to kind of route through the city via various steepnesses. So if you're on a wheelchair, you only can tolerate I think an 8% incline, versus if you're on a motorized wheelchair, you can tolerate much more larger inclines. So you can kind of limit it to different things, and it'll help you route through different areas of the city. Because Seattle's a more heavily hilly city, I think this tool is much more useful for them. But I think using elevation as a basic example is really helpful, because elevation, we currently have that data. We currently don't have the data for a lot of the ped ramps. So another thing to note is that Seattle kind of has their curb cut data kind of already integrated into their data set. So they can also filter for curbs that are not raised and curbs that are flush to the sidewalk. We currently don't have that in New York, so we kind of have to use some guesstimation of, if there is no ped ramp there, we're going to just assume that that is accessible. This brings us to my first example using OSM and QGIS to kind of create walk sheds using elevation as barriers. If you're not familiar with QGIS, QGIS is a free and open source GIS software that provides a few awesome plugins and also allows you to just get into just mapping data and also doing really simple analyses. In ArcGIS, there's a bunch of more powerful packages, but kind of ArcGIS costs money a bit. And NetworkX is an additional package for network analysis that will set you back a lot, and it's mainly used in transportation agencies. So we want to stick with the free stuff for this example, so y'all can get your hands on it. So in OSM, there's something called OSM Overpass, which is the primary API to kind of access OpenStreetMap data through their database. So you kind of just have to specify what kind of feature you want. So if you want a node, you want a way, or you want I think it's called, I'm not sure what the area is called, but yeah, if you essentially want a point line or polygon feature, and then you specify the tag. So in this case, I'm specifying, I'm using a cheat way to get all the sidewalks and all the paths that are accessible by pedestrians or people on wheels. I'm using highway equals footway, which will get generally the whole entire universe again of stuff. The tool here I'm using is Overpass Turbo, which is kind of this web-based interface of it. You can do really small queries with it, but larger queries tend to crash your browser. So I usually just test out my queries here for a small area. And then in QGIS, I use different plugins to download my data. But essentially, if you run this query here, or if you just click on wizard and then you just type in highway equals footway, you can get all the footway nodes and ways. And then from there, you can download as GeoJSON, or you can download as a KML or anything like that if you want to use this browser method. If you're not interested in footway data, you can also get a ton of other query data from OSM. So if the sidewalk data is really sparse for your area, or you're not interested in sidewalk data or street data, you can always use the OSM tool to identify a feature, and then you can plug in a tag. So if I want all the shops that are florists, I can just type in shop equals florist or something like that, and you can get all the nodes for that, and you can extract that information for your analyses. So continuing on, there's this really helpful plugin in QGIS called Quick OSM. And I essentially did the same thing that I did in Overpass Turbo, but in Quick OSM, highway equals footway. And then I also did it for, I did it for curbs, and I also did it for crossings. So I essentially kind of get this map here. And you can see that there's some spots in Flushing that have not been mapped yet. But majority of the central business district here has been mapped. So we can actually start kind of creating a really rough mobility map. I'm going to start at the library, because the library is usually the most center point when I kind of think of Flushing. So I'm gonna create just a really simple mobility map using this plugin called QGIS Network Analysis Toolbox, which kind of just makes it really easy. So essentially what you can do is you can plug in all the footways, and then from there you just select a start point. There's also a ton of other features. You can like import a ton of start points, or you can also import end and starting destinations, and it will calculate the travel time between them. So it's a really just useful tool that you can just plug and play with. It does and its analysis relatively quick, and it will generate this chart here. But the issue with this chart is if you just plug in data out of the box, there's no barriers, there's no weights to anything. So yeah, this is kind of like if you just magically can go from one street to another without any barriers or any elevation change. So what I did was, well, I'm just gonna go back to routing, my bad. So essentially you can add barriers to routes. So when you add barriers to your routes, you can delete segments, or you can delete connections with other segments. So if I go back to here, you can see that there's these blue dots these cyan dots that represent crossings, and there's these blue dots that represent crossings. Ped ramps. So if like a ped ramps is not accessible and you set the filter to be such, or you want to set your analysis to be such, I want to find all that the people in this area can move if they can only travel through accessible ped ramps. So you can actually just filter out for the non-accessible ones, and you essentially delete the connections on a network. And then the program has to kind of reroute through another street, and that causes an extra distance cost. And next, again, you can kind of just add a layer of cost by just specifying, hey, this street takes an extra 10 minutes to go on top because there is this extra height or incline that the pedestrian has to go through. And that's what I essentially did for the next step of this analysis. So what I did was I essentially added a speed field. So speed field, if you play around with network analyses, or if you think of it in the sense of cars, you have speed limits on specific streets. So you want to specify, hey, you can travel this fast on larger streets. But in this case, I'm using the speed field as if you're climbing up a hill, you're going to relatively take longer, and you're going to relatively take a slower speed up that hill. So I kind of wrote just a really simple formula. I'll share the slides later, and it will have that in much more in depth. But for the sake of time, essentially, I kind of just slowed down the speed for areas that have a larger incline. So from the elevation map, I generate this incline of sidewalks and paths in my area. And there's a lot of areas along the park here that are lower elevation. And there's some like major hills right here. This is like the Mary Hill area here. And here is more industrial area that was less, like, I guess there's slightly more hilly here too. So yeah, there's a lot of barriers to kind of traveling around this area. With that, I added that additional speed fields, and then you can kind of create a more accurate isoline or these walkable sheds for your area just by clicking a couple of windows. You may notice that there's this like spot here that's kind of artifacted. This artifact kind of carries throughout. So here there is also that artifact. And if we actually look back into data here, I'm not sure if we can see it here, but essentially there was no crossings connected here. So QGIS kind of assumed that there was kind of like a barrier there. And so it's essentially the spot you can't really travel to because there's no connections there in the network. But that would kind of simulate like if there was an actual barrier of like construction or something like that. And then we kind of go to the Python example. So I'm just going to spare you reading the code, but essentially there's this really awesome library called OSM and which will automatically just pull all the data for you from OSM. You can just specify that you want all the network type walk. This is kind of useful if your neighborhood doesn't have any sidewalks already mapped, because OSMX will automatically kind of assume that there are two paths along each road. So essentially right now I have like just duplicated sidewalks. So what additionally I need to kind of do is just additionally add this custom filter. This custom filter is actually really useful. In this case, I kind of just use it to filter for highway footway, which is what I did for the QGIS analysis. And this will just really easily clean up and only include the data that I know is kind of quality and also is only mainly sidewalks. Yeah, this custom filter is really useful. You can, if you're working with power line data, I know there's some Con Ed people here or something like that, which is kind of weird. But yeah, you can specify that that you only want power lines, or if you want to only study like motorways, if you want to study busways, there's a way for you to kind of filter those and generate your own network and your travel analyses and mobility analyses. But yeah, essentially I kind of just filtered down for my sidewalks. And then it's just that simple, like just plug and play. I just copy and paste a ton of code here, which essentially just estimates the meters per minute through your neighborhood. So if this was a flat land, this would kind of be the ISO areas or the walk sheds for your area. If like all these streets were kind of essentially flat. But we can kind of build those barriers onto this data set. So using Python, we can input our digital elevation model, our height model, and then from there we can just calculate the incline again. But in this case, we're automating this, so we don't have to kind of redo this anytime there's new data that comes into OSM, or if we want to kind of just modify this or add certain barriers, we can kind of just really just fine tune this and just rerun this analysis really quickly instead of going through all the various interfaces in QGIS. So that's why I kind of like automating a lot of stuff. But essentially what I did here was I essentially pulled out the start and end points of each street and calculate the incline. And from there, I said that if the incline is greater than 20, it's going to take 6 times as much as effort. But this isn't really subjective here. So I really encourage you, if you're really interested of trying to figure out how to calculate the time it takes to climb an incline or the effort it takes to climb an incline, read up on Toller's hiking function, which is what AccessMap kind of uses. But the end product of here is you kind of generate the same thing I did in QGIS, but again, it's automated, and you can see that more hillier spots take longer times to get to. And that kind of brings us again back to the conversation of what data sets to use. Yeah, like OSM is kind of sparse, so you can only do in certain neighborhoods that are already mapped. You can use OSM mix to kind of guesstimate where sidewalks are, but that might not be accurate. So you might be inclined to use the sidewalk data. So yeah, that's kind of the end to my kind of really weird presentation on mobility and kind of using OSM data to kind of measure that. Hopefully it was kind of useful to y'all. And I guess I'm just going to open it to questions if you have any questions.
I'll ask a question. Can you hear me?
Yep, I can hear you, Chris.
Okay. Yeah. So my question was, I think DOT is the one who installs those crossing, those what do you call it, the surfaced intersection things, pedestrian ramps. Thanks. Do they have a data set of that? That's
so it's not public. It's not like definitely publicly accessible, but on their website, if you go, I think if you just search up NYC ped ramps, there's a map there, and then it's on top of this. It's on top of ArcGIS online layers. So you can technically pull those layers out. If you're thinking about kind of just importing those layers into OSM, that's kind of frowned upon, like because yeah, OSM kind of wants people to kind of contribute their own data and community check that data.
Okay, yeah, but if you got it, you could take it, you could get it from DOTs, and then you could maybe integrate it somehow.
Yep.
But
importing data takes a long, like it's a huge process in OSM. But yeah, if you want to use it for your own analysis and build your own models, it's definitely very useful to use that data set.
Your process really just works strictly off of OpenStreetMap and doesn't integrate other data sets at the same time, right?
Yeah. Well, I imported the elevation models because OSM doesn't have that and doesn't store that data. So that was an example of joining data sets to your network analyses. So if you're doing it in Python, you can just simply do like a spatial lookup, like, hey, what is nearby on the street, or you can get an associating street ID. So if there's an open restaurant or if there's a lot of complaints about blocked sidewalks, you can integrate that as a weight to your line.
Okay, cool. Thanks. And the elevation model you used, you got that where?
Got that on an open data portal. It's the 1 feet DEM. I recommend you using use the float, which is a really huge data set. It's like 20 gigabytes. But if you use the float, it's much more accurate. I'm using the integer number one, which kind of like increases, like has a lot of errors in it. Where like when a street's crossing over a highway, sometimes the street takes the elevation of the highway instead. So if the highway's lower down, your slope just is like really high. So yeah, those are some small considerations if you're using that elevation model.
All right, cool. Thank you.
I have a quick question.
Yep.
So Vision Zero, how is that incorporated into some of the stuff that you're doing?
So there's a lot of there's something called street improvement projects, and there have been mostly scattered throughout the city, but there's some inequalities in certain neighborhoods. I know the DOT has been prioritizing certain areas, but essentially there's various projects on widening the sidewalk, so it's much more safe for pedestrians or increasing capacity for the sidewalk. And there's also a lot of traffic calming measures that we can kind of measure through the street improvement projects, that we can like kind of weight these streets as a lot more higher and more desirable to travel through because they're technically more safer infrastructurally.
Cool, thanks.
Hi, I have a question. This is Joanna. Have you played around with putting 311 data, like about places that are being chronically reported as having cars parked on the sidewalk and that sort of thing, and then mapping your routes with those barriers in place, like places where you can pretty much be sure there's a cop on the sidewalk kind of thing?
Yeah, like if I think for traffic agencies, that's probably what they do a lot of the time. Well, not for the 311 data, but for traffic agencies, they kind of put like warnings on certain areas. Yeah, if this system was like largely more integrated to that system, I think it would be like a really smart system. But yeah, a lot of this data takes a lot of time to maintain, especially with 311 data. 311 data is really messy in a way where locations sometimes aren't where they're supposed to be, and you're supposed to snap them to like the road or snap them to a sidewalk. So it's
and there's no way to report things geolocate in parks or like large traffic circles or that kind of thing. But yeah,
it's a bit hard. But yeah, I guess like if someone wants to come up with like an app that will collect community input, and then also create these like warnings of certain areas, like how Google or Apple Maps does it, like, oh, this street is closed because of X. I think that would be useful, just creating a map dedicated to pedestrian routing. I got a question in chat from George. Can you use your mobility analysis to identify locations that have low mobility? Kind of like an inverse ISO time plots for your travel times. Yes, you can. So what essentially you can do, I think, is that you would just think about it the other way, like where do people want to go? So in this case, like we can use the case of vaccination sites. So if you want to host a vaccination site in City College, City College is on a hill in Morningside Heights, so it's kind of hard for folks for Harlem to get to. So you can kind of work that analysis the opposite way around to figure out where there's areas of low mobility to get to your vaccination site, or get to your store, or get to wherever you desire people to go to.
Thanks.
See, it looks like actually I have a few questions in the chat that came in earlier. Do you want me to read one of them?
Yep, go ahead.
Okay, looks like the first one came in from Calvis. Please forgive me if I'm mispronouncing your name. But it says, do you do any outreach to local community organizations that can help fill out your walkable map?
I don't currently do outreach since BetaNYC's team is so small, but there's a ton of mapping, really happy mappers in New York City. And and like, especially, I just want to shout out Daniel Slow, but he's been really pushing a lot of OpenStreetMap lessons to teach people how to use OpenStreetMap so they can kind of help out. I think we previously made a lesson to kind of like help people kind of learn how to use OSM so they can start mapping out areas, adding sidewalks, or adding out bicycle infrastructure, or other important like stuff like stores. I think we were doing supermarkets in one time during the quarantine, and I was trying to throw all that data into OSM, but yeah, there's just a ton of data to kind of map. And yeah, I think there should be kind of like a push to kind of get more people to map that data.
Okay, great. All right, and it looks like another question came in, Z. Looks like it's from Yeshio Kirschner. Again, forgive me for mispronouncing your name, but question says, what's the best way someone with a non-technical background can contribute to these resources?
Yes, so I think that goes back to learning OSM. There's a ton of resources on YouTube to learn it. Yeah, also Daniel's hosting a session, I think this Saturday, to teach people how to print out paper maps, and then from there mark infrastructure on those paper maps, and then from there how to bring it onto OSM. So yeah, there's a ton of resources to to learn OSM, so you can start adding features and attributes onto the map, so we can get more sidewalks or any other interesting phenomenon in New York City mapped. A lot of mapping. Yeah, and hopefully next year, or like maybe in the upcoming months, I can, or somebody can host a workshop on getting folks comfortable with mapping themselves in OSM. And then I'm just going to hop into these questions really quickly. Can Mapillary videos or photos be helpful? Yes, I've been using Mapillary a ton recently when going through hikes. There's a ton of like paths in Staten Island that kind of connect to people's backyards, or paths that connect to roads, which is pretty interesting. So yeah, I kind of use Mapillary a ton. Mapillary doesn't really cover a lot of the areas in New York City, so I alternatively use a couple of other street views. So Google Street View, of course, is the main one, but City has their own street view that they kind of have that only city employees kind of use, but I kind of use that too because it's formerly an intern kind of. So I like using that because that's high quality data, and also it's more temporal. So there's various, it's recorded, I think, every 6 months or something like that. So you can kind of see changes throughout the years. And thank you for, Michael, thank you for posting the OpenStreetMap task projects.
I have a question about that. I just took a look at it, and I just saw one project in Brooklyn that is community board based. Is this something that community boards can come to the OSM folks with and say, we'd like to do this, and then it becomes a project? Is that how it works?
I think this would be, you would have to go through, you can go through let me backtrack here. So the task manager is mainly for folks of the OpenStreetMap community. So you should probably outreach to either me, I'm not sure if Daniel's here, but Daniel can help you set up a task on OSM. And then people from all over the world can kind of contribute through these various smaller areas and cells. But if you're looking for really specific community data, what I recommend you to do is probably contact me so we can figure out if there's a way for us to kind of host like a mapathon event or something to kind of find those little smaller features.
Great. Okay.
Yeah, so the main point of the OSM tasking manager is to use satellite imagery to kind of search for features. So it might not be what you want if the feature's not in satellite imagery. What is the title of the event on Saturday? Let me find it. I think it's something with bicycle infrastructure, but you don't have to map bicycle infrastructure if you don't want to. I'll send it over later, Robert. I don't think I can find it right now. I'll send it over to you later. Oh, there you go. Thanks. Yep, the scavenger hunt. Yeah, it's on Saturday, March 13th, 1 to 2, but it can probably be in your own pace. So I think MT asked the question previously. Yeah, maintenance can be a challenge. Can you automate updates, or is there any thoughts about keeping the data updated? So again, OSM kind of frowns upon like automation or any like batch updating, but essentially, yeah, I guess it can be possible that there can be someone from the community that will update stuff, like connecting it to the bicycle events. The bike scavenger hunts. Essentially, for that project, somebody, I think, an account called City Racks kind of added a bunch of bike racks 7 years ago, but some of them aren't accurate, and for some neighborhoods, there's additional bike racks that are added in areas. So yeah, there's ongoing like events that kind of have it's got ongoing events to kind of update features on OSM to kind of get that push. But yeah, if you're dealing with street infrastructure or if you're dealing with buildings, sometimes that really changes. So I don't think there needs to be that much of an automation process for that. David, let me find that street widths. It's called street widths or something. Yeah, sidewalk widths, my bad. Here you go. That's the link for the events. And thank you, Michael, for posting the website. Yeah, it has all different cities too. Yeah, thank you all for listening in.
Thanks, bye.